What's up, guys? Fantasia here with the second part of part 8 of the Allegro programming tutorial series. And in the previous video we discussed how to create objects using procedural code in C++ using Allegro, and in this video I want to cover how to address the issues of procedural code using object-oriented programming, which will allow us to use classes to create video game objects in our game. Object-oriented programming is a feature of C++ that will allow us to encapsulate or bring together or integrate multiple attributes of an object into one single entity. That's why it's called object-oriented programming, because all of the attributes and functions, if you will, of the object it's collected into a single object instantiation. So I don't want to go into too much detail on how to create a class and how to declare class member functions and variables, because that's a feature of C++ that I think would be better if you went and watched the tutorial on classes and object-oriented programming. However, I will cover how we can create the objects that we're going to use in our games using classes. So let's get started. So this is what our code looked like from the previous video, where we had a Mario bitmap and then his X and Y, and then we had Sonic's bitmap and then his X and his Y, and then we drew them down here in our drawing portion of the game loop, and then we destroyed their bitmaps after we exited the game loop. So what we're going to want to do is, in order to create an object of Mario, what we're going to want to do is create an object class, because every time that we create or want to create a new character, we have to create a new bitmap, a new X, and a new Y, and that can be problematic when you have let's say 50 enemies on the screen. You'd have to each manage their own bitmaps, X's, and Y's, and that can be a problem. So we're going to create a new object class. So create an empty file, call it object.h. Okay, and so the first thing that we're going to do is declare our class, and then call it maybe object, something that'll represent our video game character, our character like Mario or Sonic. We'll just call it an object. Both of them will be called objects. And so within our class we're going to go ahead and create our constructor and our destructor. So this is the public. And that is our constructor and destructor. And now we're going to create our functions that each of our objects will be able to do. That we'll be able to call those functions, and the object will do it correspondingly. So the first thing we have to think about when creating an object class is, what do we want our objects to do? Well, we obviously want them to move, so maybe we can create a move function, but they can move in different directions. So maybe we'll create a move down, move up, move left, and move right. So these are the functions that every object will be able to do. And maybe that's it for the functions. Now we have to think about the data that each object shall have. So we'll put the data in the private section of our class object, because we don't want to mess with the data. We will have our functions mess with the data that are public. So each object shall have an X and a Y, because that's where they get drawn into the screen. And also each object should have a bitmap, of course, that represents their image. We'll call it a sprite. And also each object is going to be drawn onto another bitmap, right? Just like in our main code, Sonic and Mario were being drawn onto the bitmap with draw sprite. So in this case, that is what's called the layer bitmap. So we're going to call the bitmap that the object is drawn onto, we're going to call that the layer. Okay? And then the sprite is simply the bitmap that represents the object itself. And the word sprite comes from the old school word that was meant to describe the pictures that the old video game consoles could show on the screen. So the sprites were just the pictures that represented the characters. And that looks it. And so we'll close our class declaration. And because we use bitmaps, which are types that are defined by Allegro, we're going to include Allegro inside of our class interface. And so now all that's left is we have to define the functions that we declared here. And we need to have a way to change or set the sprite's bitmap, the object sprite and the layer. So we need to have a set layer function and a set sprite method as well. Actually, we will set that to a path. So constant there. So now the reason I set it as a path is because every time we want to set our sprite to set the picture of what represents it, we will give it a path name that represents our picture. So like the path for Mario would be Mario.bitmap. That's the path. Okay, and now all we have to do is declare these. So first thing we have to declare is the object constructor. We'll go ahead and include our object file, and then we'll include Allegro as well, because our object class uses Allegro functions. And so the constructor look like this. We're going to set layer equal to a null pointer, and then set the sprite equal to null as well. And we'll be able to set the layer and the sprite via setter functions. We'll set x equal to 0 and y equal to 0, just so the object will have an initialized value. Then we want to declare the destructor, and every time that we call delete on our object pointer, we want to destroy our sprite bitmap. And the other functions we defined were set layer, set sprite. Okay. Set layer shall take a bitmap pointer. So layer equals bitmap. I put a tilde where it did not belong. set sprite, take a constant character, we'll path, and sprite equals load. The path is path, what would pass it in, and then the palette is null because we're ignoring palette settings for now. And then that's all that's left to define is the movements. Move down is Y plus equals 5 is a good value. Move up. Minus equals 5. Move left is X minus equals 5, and move right. I think it's actually keeping track of the ones I define. That's really slick. And that should be all. Right, left, up, down, yeah. And so now in our main program we include our interface to the class that we just made, object.h. And now what we can do is now, instead of having a Mario bitmap with an X and a Y, which are 3 separate pieces of data, we create one object pointer to Mario, set it equal to a new object, and so now this line right here will create a brand new Mario object with all of the settings that we set in our object .cpp here. And so what we first thing we want to do is set the layer. Set the layer to bitmap. Then set sprite to and then what's cool here is we will now replace this with Mario's move left function. Move right. Move up. Then Mario move down. And so this is much cleaner and easier to understand what we're doing than incrementing and decrementing X and Y values. And actually there's something I forgot, because now we can actually create a draw function in our object that will actually draw the object onto the sprite or onto the bitmap for us, which is very convenient. Draw. So every time we want to draw our object, we simply do draw sprite. The sprite will be its own sprite, and then the layer will be layer, its X and Y. And so now we've done that, we can just call Mario draw. But instead of destroying Mario's bitmap, we're going to delete the Mario pointer. And that looks right. We shall see if that compiles. It does not, because I did not set my return statements to what they should be, which is void. draw. And that works. Now, when we run this, Mario does not show up for some reason. That's interesting. Let's see why he doesn't show up. Mario.draw. Strange. Let's see. Mario equals new object, set layer to bitmap, set sprite. This is a mystery. Mario has disappeared off of the face of the world. We're calling draw. Draw sprite. Maybe that's in the wrong order. It is. I should be calling the layer here and the sprite here. There. I forget the parameter orders sometimes. Okay. Now when we recompile it, Mario is here. There we go. Now, this is essentially the same thing as before, except Mario is declared as an object. And so now that makes him a single object instead of three variables, a bitmap, an x, and a y. Because this is our Sonic object. Well, it's not a real object, but it's a collection. We're treating it as one. But this is one Mario object. And actually we can do the same with Sonic. And we will do that right now. Sonic equals new object. And then Sonic set layer to Sonic set bitmap, or set sprite to Sonic dot bitmap. And now we can say Sonic dot, A is move left, move right, move up, and move down. And so now we can also say Sonic.draw, or Sonic dereference draw, and now we destroy or delete Sonic at the end. And now that should take care of everything. And now Sonic moves. This is essentially the same code as what we had before, except now they're both objects now. And it's much easier to manage. See, all we had to do was call move left, right, up, and down, and that essentially makes sense, instead of objects X and Y being incremented and decremented. So this is very nice, because now if you wanted to create multiple objects, like more than Mario and Sonic, you could make a loop, you know, for instance, that creates like however many number of objects you want to create, really, and they will each have their own X and Y's, but it is built into the object and not outside the code as, you know, an integer X and an integer Y. It's all built in. All of that is inside of the object that we made. So that's what makes it nice, because it makes code easier to read and it makes it easier to maintain, and it makes it less error prone in the end run. So that's that for making multiple objects with object-oriented code. And in the next tutorial, I hope to cover how we can enhance the object class to make objects do more complicated things, and in the end we'll make whole games with objects. This is essentially what a game is. It's full of game objects, right? So yeah, cool guys, sweet. Till next time, Fantasia signing out.